Good morning everyone. I am Moni from Basic Chemistry Honors first year. Today I am read a chapter Cycloalkenes. Introduction. Cycloalkenes are unsaturated alicyclic hydrocarbons having a carbon-carbon double bond. Their molecules general formula is CnH2n-2. They are named by adding a word cyclo to the name of the straight chain alkenes having the same number of a carbon atom as a ring. The double bond is always taken to be located between carbon 1 and 2, and therefore it is the position needed to be specified. Cyclopropene, cyclobutene, cyclopentene, 1 methyl cyclohexene, 1 3 dimethyl cyclohexene. Methods of preparation. Cycloalkanes are generally prepared from other cyclic compounds by beta elimination reactions such as dehydration or dehalogenation are given below. By dehydration of alicyclic alcohols. As in the case of open-chain alcohols, dehydration of alicyclic alcohols to form alkanes is brought about by heating with the concentration sulfuric acid. For example, cyclopentanol react with sulfuric acid in presence of heat gives cyclopentane plus water. When 2-methyl-cyclohexanol react with sulfuric acid in presence of heat gives 1-methyl-cyclohexane and 3-methyl-cyclohexane, more highly substituted cycloalkanes. It may be noted from the dehydration of 2-methyl-cyclohexanol, that is dehydration of substituted alicyclic alcohols. The more highly substituted cycloalkane is the major product by the dehydrohalogenation of alicyclic halides. When treated with the bases such as alcoholic QH, cyclic halides form cycloalkanes. For example, cyclopentene bromide react with alcoholic QH in presence of heat gives cyclopentene plus KBr plus H2O. When 1-chloro-1-methyl cyclohexane react with alcoholic KOH in presence of heat gives 1-methyl cyclohexane and methylene cyclohexane 94% and it is 6% respectively. Chemical properties of cycloalkanes. Cycloalkanes exhibit the usual properties of alkanes. They undergo electrophilic addition reaction in which the using remains intact. The important reaction of cycloalkanes are given below. Addition of hydrogen. Cycloalkanes undergo catalytic hydrogenation to form cycloalkanes. For example, 1,2-dimethylhexane react with hydrogen in presence of platinum gives cis-1,2-dimethyl cyclohexane. It may be noted that the addition of both hydrogen to be double bond take place from the same side. Cis addition take place. Addition of halogens. Cycloalkanes add on halogens to form cycloalkanes. In case of hydrogenation of cycloalkanes, addition of halogen to cycloalkanes, it is a trans addition. It is a trans addition such that the two halogens are added from the opposite side of the double bond. For example, cyclopentane react with bromine in presence of CCl4 gives trans 1,2-dibromocyclopentane. Addition of halogen acids. Like alkenes, cycloalkanes undergo electrophilic addition halogen acid according to Markovnikov's rule. These reactions also involves the trans addition examples. Cyclohexane react with HBr in presence of cyclohexyl bromides, which gives the cyclohexyl bromide. When methyl cyclopentane When methyl cyclopentene react with HCl gives 1-chloro-1-methyl cyclopentane. But addition of HBr in the presence of peroxide take place to against the Marconi's of rule and follow free radical mechanism. For example, 1-methyl cyclopentane react with HBr in presence of organoperoxide gives 1-bromo-2-methyl cyclopentane. The reaction takes place by the following mechanism. ROOR react with heat in presence of heat gives 2 RO radical. RO radical react with HBr gives ROH plus Br radical. This Br radical attacks the 1-methyl cyclopentene and forms the 1-bromo-2-methyl cyclopentane. Addition of a hydrohalose acid, formation of a halohydrous. Cycloalkenes react with hydrohalose acid and hydroborous acid to form the transhydration. Example: cyclopentene react with chlorine and OH in presence of a chlorine water. It gives the term trans 2-chlorocyclopentanol. Addition of carbene or carbenoids. Cycloalkenes undergo addition of carbenes or carbenoids to form bicyclic compounds. For example, cyclohexane undergoes Simonson-Smith reaction with the diiodomethane in presence of zinc or copper, couple as shown below. Cyclohexane react with CH2I2 in presence of zinc, copper at presence of ether as a catalyst gives bicyclo-4,1,0 heptane. Hydroxylation. Cycloalkenes undergo hydroxylation on treatment with potassium permanganate or osmium trioxide to form the cis-glycose or diols. For example, cyclopentane react with KMnO4 gives cis-cyclopentane 1,2-diol. Ozonolysis. Ozonolysis of cycloalkenes result in the cleavage of ring system of the site of double bond, forming a dicarbonyl derivative with the same numbers of carbon atom. The reaction can be used to locate the position of double bond. For example, alkyl cyclohexane react with O3 gives ozonide and dicarbonyl derivatives. Allylic halogenation. Like alkanes, cycloalkenes also undergo allylic halogenation under suitable conditions. Cyclohexane react with NBS gives 3-bromocyclohexane. Conformation of cycloalkenes due to sp2 hybridization of the carbon atom constitutes the double bond of cycloalkenes. These two carbon atoms and the atom directly attached to them must lie in same plane. Therefore, for the first two cycloalkenes, cyclopropene and cyclobutane, all the ring carbon atoms lie in one plane. On account of a large angle strain in them, these molecules are highly strained. Cyclopentane is also supposed to be nearly planar but very little angle strain. Cyclopropene planar, cyclobutane planar, cyclopentane nearly planar, cyclohexane no planar. In contrast with the smaller ring cycloalkenes, cyclohexanes and larger cycloalkenes exist in a structure-free non-planar or a pucked conformation. In cyclohexane, carbon atom 1, 2 which are sp2 hybridized and 3, 6 which are directed attached to 1, 2 respectively lie in same plane. But in order to maintain the proper bond angle out of carbon atoms C4 and C5, one line lies above and other below the plane. The causes the ring assumes the half chair conformation. To such a conformation becomes possible, which is equilibrium with each other. Both of these conformations, bond 2C4 and C5, are normal axial, A equatorial and B but not equatorial. Bond of C3 and C6 are pseudo or equisic axial and pseudo or equisic equatorial. It may be noted that the conformation in which both C4 and C5 are above the plane C1, C2, C3 are and C6 would be highly strained, such as conformation known as half-Ford conformation. It is highly unstable. It is highly unstable. Thank you.